So welcome to What's Up Over Edmonton for November 2023. My name's Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada, Edmonton Centre. And I put this picture from the October 14th partial eclipse. The moon covered 53% of the sun on that Saturday morning, and we had a really, really good turnout at the RASC Observatory in Coronation Park. And I noted that we were on all three of the local news channels, and the CTV report even made the CTV national news that night. So good on us. I call this What's Up Over Edmonton because the skies over Edmonton are fundamentally different than what's presented in a lot of the popular astronomy publications like Astronomy Magazine, Sky and Telescope. For example, this is the sky over Toronto on July the 5th at 11 o'clock. And I always point out this constellation here, Scorpio, fully above the horizon. Where in Edmonton on that same day, at that same time, we only see the very top of the Scorpion. It never rises much higher than that in Edmonton. We never see its tail or stinger. Also, it's not only what we could see, but how we see things. So this is a picture I took last February of the moon in the upper left with Jupiter in the middle and Venus on the lower right. And you'll note that they are in a slant. And I just took that picture in my backyard. At the same time, my wife's cousin was in Buenos Mexico, which is at 20 degrees north latitude, on that same night, and took a picture of the same scene of the moon, Jupiter, and Venus. But you'll note that it is in a straight line down to the horizon because the ecliptic runs that much higher from there. Most of the information I use comes out of the Observer's Handbook, which is put out by the RASC every year. It is 352 pages of just about anything you would like to know for the amateur astronomer to do observing. So, what do we have in the sky this month when the winds of November come early? November traditionally is probably got the worst weather for sky gazing all year. So hopefully we can see some things. We have two oppositions and one superior conjunction. We've got Venus prominent in the morning sky. It's been that way for the last several weeks. We have the Leonid meteor shower, which peaks on the morning of the 18th. And we have daylight saving time ending on November the 5th, this Sunday morning. So I'll go on with the planetarium portion. And as always, I have pre-recorded it. Let's have a look at what we can see in the skies over Edmonton in the month of November. And as always, we'll start with sunrise and sunset times. So on November the 1st, the sun rose at 8:33 a.m. It set at 6:01 p.m. for 9 hours and 28 minutes of daylight. And night will officially begin at 8 o'clock p.m. And these are all Mountain Daylight times. On the 30th of November, the sun will rise at 8:25 a.m. It will set at 4:19 p.m. for 7 hours and 53 minutes of daylight. And night will begin, that is, astronomical twilight ends, at 6:27. And those are Mountain Standard Times. We've had the time change. Let's look at the planets. Now, normally I start with the evening planets, but I'm going to start with the morning planets this time. Well, actually just a planet, which is Venus, which has been blazing very bright in the morning sky in the east-southeast for some weeks and will continue to be a very bright object in the sky for the next several weeks. This morning on the 1st, it rose at 4:03 a.m. and it will continue rising fairly early, especially with the time change. By the end of the month, it's rising at 4:12 a.m. Mountain Standard Time. Now, if we look at Venus through a telescope, and we'll just zoom in on it, There we go. Its phase is past half, and it is now a gibbous phase, as more and more of its surface is illuminated by the sun as it moves in its orbit. But as it moves in its orbit, it gets further and further away from us. And as we advance through the days, you can see it getting smaller and smaller. And by the 30th, it has shrunk quite a bit compared to the way it looked on the 1st. There's the 1st. And there's the 30th. And this is the path that Venus will be following in the sky for the next several weeks. And moving into the evening sky, we have the parade of the giant outer planets, starting with Saturn in the west and ending with Uranus in the east. So let's start with Saturn, and we'll turn on our constellations. And as you can see, Saturn is in the constellation of Aquarius. And through even a small telescope, a 60 millimeter refractor, you'll be able to make out Saturn's ring system. And in a larger telescope with more light gathering, you can even see the Cassini division, which is that black line between the A and B rings. And you can see some of its moons also. Saturn is slowly making its way westward. At the beginning of the month, it sets at 1:53 a.m., and by the end of the month, it's setting at 11:03 p.m. Mountain Standard Time. Next in line is Neptune, the 8th planet from the Sun. It is just hanging on to the border of Aquarius and Pisces. There we go. Neptune is this beautiful blue disk. You need a mid-sized and larger telescope to appreciate the blue disk. And you may even make out its giant moon, Triton. And there's Triton there sitting off to the left. Neptune is up all night. It sets at 9:52 a.m. on the 1st and 6:51 a.m. on the 30th. Next we come to Jupiter, king of the planets. Jupiter reaches opposition on the 3rd of November, which means it will be rising as the sun is setting, and it will be up all night. And opposition, of course, is when the sun, the earth, and the outer planet all line up in a straight line. It also means it's the point in the year where that planet is closest to Earth and gives us the best views. At the beginning of the month, Jupiter rises at 6:06, sets at 8:38 a.m. By the end of the month, it's setting at 5:29 a.m. And I have to say, when I get up in the morning, I look out my eastern window and I can see Venus blazing brightly, and I look out my western window and I can see Jupiter blazing not quite as bright, but it's nice to see the two brightest planets in our sky at the same hour of the day. Now, if you have a medium or larger telescope, you can watch shadow transits across the face of Jupiter. And this is when one of the 4 Galilean moons, one of the 4 big moons, crosses in front of the planet, and its shadow is projected on its cloud tops. Now, when the planet is near or at opposition, the shadow follows very closely behind the planet. And this is an example here. This is on November the 10th, and I'm starting the time at 8:15, and I'm just going to run this little simulation. And this is a shadow transit by Europa. Now, you can see Europa on the lower left. So let's start the simulation. There's the Europa crossing in front of the planet, and there comes its shadow. And you can watch this over a period of time as the shadow of Europa, and indeed Europa itself, cross across the face of Jupiter's cloud tops. So we're coming up to 10:45, and Europa's left the building, and there goes its shadow, leaving the planet about 11:11. So that's something you can watch for. And finally, we come to Uranus. Uranus reaches opposition on the 13th, just 10 days behind Jupiter. And so it is going to be up all night. At the beginning of the month, it's rising at 6:19 and setting at 9:52 in the morning the following day. And by the end of the month, it's setting at 6:51 a.m. The following morning. And in a telescope, it presents this pale blue, almost a turquoisey kind of disk. We haven't talked about Mars for quite a while because, we just haven't been able to see it. It's just been too close to the sun. And in November, it is going to be in what we call superior conjunction. That is, it will be behind the sun from our point of view. And here is an overhead view of the solar system, and you can see here is Mars, and here is Earth. And if you draw a line between the two, the sun is in the way, and we just cannot see it. Mars will reemerge in the morning sky in the coming months. We'll just briefly talk about Mercury. There it is there. This is 20 minutes after the sun sets. It is just hugging the horizon, still lost in the twilight. You probably won't be able to see it anyway, but I just thought I would mention it. It's Mercury is not well placed this time around. Let's talk about the moon. On the 9th, it will be very close to the planet Venus in the early morning sky, about a degree and a half away. Actually, in parts of Europe and England, the moon will actually occult Venus. It'll pass right in front of it. But we don't get to see it here in Edmonton. Moving into the evening sky, on the 20th, it is passing Saturn. On the 21st, it is near Neptune. A few days later, on the 24th, it is near Jupiter. And the following day, on the 25th, it is near Uranus. One last thing before we leave the moon. On November the 19th, starting around 9:30 p.m., you can see the lunar X and the lunar V. This is a transient phenomenon that lasts for about 4 hours, happens just before first quarter moon, and it's sunlight falling on the tops of craters near the terminator. And now the moon sets at about 11:50 that night. So really, before the moon gets into the muck near the horizon, you have about an hour or so to see this phenomenon. If you've never seen it, give it a go. You need a telescope. On the evening of the 17th and the morning of the 18th, you have the Leonid meteor shower, and there's Leo rising there. The Leonid meteor shower is a result of the Earth passing through the trail left behind by comet Tempel-Tuttle, which has a 33-year orbit, and typically has an outburst every 33 years when the comet is in our area. It will next be in close to Earth in 2032. I recall back in 1999, I witnessed a meteor storm, and that's the only time I've ever seen it, where there were literally hundreds of meteors falling. There were so many meteors falling you could not count them. Hundreds an hour were falling. It was quite spectacular. So 2032, something to look forward to. There's the radiant there. It rises at 11:42 when it comes above the horizon, so it's definitely a meteor shower for the morning of the 18th. As always, get away from the city, get away from city lights. Take a chair with you, take a blanket, take something warm to drink. You don't need binoculars. You definitely don't need a telescope. It's great to observe with a friend and watch the show. Typically, you get 20 to 30 meteors an hour with the Leonids. On the morning of November 5th at 2 a.m., we set our clocks back 1 hour. Daylight saving time ends. We're back on standard time for a few months, and stargazers rejoice because it gets darker that much earlier. Look at a couple deep sky objects here. So this is 9 o'clock in the middle of the month. And if you're looking at Saturn, cast your gaze a little bit to the east, and you will find the Helix Nebula, which is in Aquarius. There it is there. In typical pictures, it's quite colorful. The center part is blue. Some people call it the Eye of God. But this is a fairly typical representation of what you'll see through the telescope, just shades of white and gray. For the Helix Nebula, this is a planetary nebula, the end stage of a sun-like star. Also in Aquarius, along with Saturn, is the Saturn Nebula. And it's called that because it's a planetary nebula, but it also kind of looks like Saturn with rings. You'll see it gray and white. But NGC 7009 is an object for a telescope mid-size or larger. And it was a favorite of one of our volunteers at our observatory in Coronation Park. The Wild Duck Cluster, which is a open cluster in the constellation Scutum the Shield, and got that name because someone thought these collection of stars like a flock of ducks flying away. And I was surprised the other night when I was out a bit later, about 11 o'clock, and I looked up and I was surprised but not surprised how far the summer triangle had moved north. A few months ago it was straight overhead, but now it's going off to the west, heading into the northwest sky. Within the triangle is the coat hanger cluster, good object in binoculars, and it looks like a coat hanger. And as fall fades into winter, we are starting to see the winter constellations. The first one to come up would be Taurus the Bull, and with it the beautiful M45 or the Pleiades. There they are there, the Seven Sisters. You can see 6 stars with the naked eye. Through binoculars, you can see dozens of stars. Through a telescope, you can almost see hundreds of stars that make up this very fine cluster. It fools people. A lot of people think it's the Little Dipper because it does have a bit of a dipper shape. But no, it is the Pleiades. It is an open cluster of stars. Fairly new stars, probably no more than 100 million years old. And near the Pleiades is Auriga, the charioteer, just off the horns of Taurus the Bull, and it contains 3 open clusters, M36, M37, and M38. There's M36. You go up a bit to find M38. Just zoom out a bit here. And M37. These are 3 nice open clusters. Can be seen in binoculars, but of course a telescope really brings them out. They're a favorite object that we like to show people at our observatory in Coronation Park. Auriga contains the very bright star Capella. Easy to spot. And if we go straight up from Capella, we come to the famous double cluster, NGC 884 and NGC 869 in Perseus. And there they are there. Excellent objects for binoculars or in a telescope. They look spectacular, and they're a favorite object that we like to show people at our observatory in Coronation Park because you can see them inside the city through our telescopes. You can't see a lot of stars in the city. We're not a very good city when it comes to light pollution, I must say, but we can see them with our telescopes. So that's about it for now, and we'll ask if there are any questions. Okay. Are there any questions, comments? Alistair, did I get everything or did I leave anything out?
No, it's all good. You're absolutely correct about November being the toughest, cloudiest month of the year. It most certainly is because we've got all this cold air moving over all this warm water that we have in lakes and of course all the muskeg up north. So it just drags down and cloud.
Hmm.
One thing to just add about the meteors is
Yep.
that there are quite a number of minor showers going on. So minor, they're typically once per hour. So nothing to deliberately go out and, but mixed in there are torrids, and they often have fireballs because they're associated with asteroid material, so they
Hmm.
burn up more brightly than typical comet dust does. But there's a decent chance if you go out and just happen to see a meteor, it's probably a torrid, especially if it's bright.
Yeah, I thought about throwing the Torrids in there because the South Torrids are on the 6th, but they're just not as sexy as
Oh,
the Leonids.
yeah, like it's one of these things where the shower lasts a whole month, and at its peak, it's one an hour. So
Yeah,
but it's just haphazard, and oh, look at that, there's one.
yeah. And the North Torrids are on the 12th, peak on the 12th. So yeah, yeah. So yeah, they are there, and I thought about it, but okay. All right. If there's nothing else, I'll move. Oh, there's a chat here. I'll just see what that's about here. How long does the average Jupiter? Oh, um, depends. Io is quicker because it's the fastest. It's closest to Jupiter, so it takes the shortest amount of time. But like the Europa one took a couple hours. Io would be a little bit shorter, and Callisto and Ganymede, which are a lot farther away, uh, will take several hours to do a shadow transit. So I just picked the Europa one because it was early evening. Um, um, but there are websites. Heavens Above probably has a schedule for shadow transits. I'm pretty sure it does. Has just about everything else in there. Okay, we'll go on to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path.
Okay, so third quarter moon is on the 5th. The moon is new on the 13th. First quarter is on the 20th. And the moon is full on the 27th. And the full moon in November is known as the Beaver Moon. It also has several other names like the Frost Moon, the River's Freezing Moon, the Morning Moon, and not morning like morning has broken, but morning like, oh, boo hoo hoo, winter's coming, I guess. And the Darkest Depth Moon is another name for it. And I always like to pick a feature from either the RASC Explore the Moon in Binoculars or Telescope certificate program. And this one is in both. And for those of you who have watched all of these or most of these, yes, I am starting to repeat things because, there's only so many features that are clearly visible. So we're going to talk about the crater Plato. And there it is there. It's up in the upper part of the moon. It's on the, it's clearly visible after lunar day 9, and it is found on the north edge of Mare Imbrium, or the Sea of Rains. It's a large crater. It's 101 kilometers across and about 1,400 meters deep. And it was formed about 3.8 billion years ago. And that's one of my pictures there. This is a closer picture I took through my telescope. And I know it's not the best picture, but I am the world's worst astrophotographer. And you can see the crater on the northern edge of Mare Imbrium. Now, you can see it here. I've put this full moon picture in because it really shows its dark floor when the sun angle on it is quite high. When the sun angle is low, it is just when it's near the terminator, you can see shadows of the crater wall projected onto the floor. But when it's when the sun angle is high, you can really appreciate the dark floor, and that's really what makes Plato stand up so much. Is that the floor is much darker than the rugged terrain around it, and this photo of the full moon clearly shows that contrast. In some 17th century moon maps, when people were not as nice as they are today, they called this Lacus Niger Major. So it was a lake and named after people in Africa. The crater was named after the Greek philosopher Plato, who lived some 2,400 years ago. And his work with his teacher Socrates and student Aristotle set the stage for the process we now call science. Now, as seen in this photo of mine, the crater floor is pretty flat. After the impact that formed the crater, it was later flooded with magma, which smoothed out the floor and covered what must have been a pretty significant central peak that we typically see in craters this size. And this better image shows a few secondary impact craters within the crater itself. And finally, if we look straight down on Plato from the Lunar Reconnaissance Orbiter, we can see that the floor is, yes, it's quite flat, and it does have a few secondary craters in it. You can also see part of the crater wall has collapsed near the edge, just indicating its age. So we'll go to the constellation, and I picked one we've never done before. Pisces the fish. It's doesn't typically get a lot of ink. This is the star field you find Pisces. And there it is with its astronomical drawing. It doesn't get a lot of ink because it doesn't really contain a lot of bright stars. In fact, it doesn't even make the RASC Explore the Universe workbook. And it is Pisces the fish. There is what people saw. This it's one of the constellations that was first cataloged by the Greek astronomer Ptolemy in the 2nd century. And as this illustration shows, it's a pair of fish facing in opposite directions, joined at the tail. The constellation is best seen in the evening sky. Oh, my pages are stuck together. The constellation is best seen in the evening sky between October and December, and it is found between Aquarius to the west and Aries to the east. And it's just south of Pegasus, the upside-down flying horse, which we talked about last month. It's notable for containing the point in which the sun crosses the celestial equator into the northern hemisphere around March the 20th, which is the beginning of spring in the northern hemisphere. This point is called the vernal equinox point. It used to lie in Aries, but it's moved into Pisces because of the Earth's wobble on its axis, called precession. In Greek mythology, the two fish represented the goddess Aphrodite and her son Eros, and in the story, they transformed into fish in order to escape the monster Typhon, Typhon was sent by Gaia, the Earth Mother, to defeat the gods. And the stories of Greek gods and the mythology sounds like a cross between a soap opera and Klingon politics. Pisces contains mostly dim stars. Only a few are brighter than fourth magnitude. And I couldn't come up with a better photo of the constellation than this one here. The constellation's brightest star is only magnitude 3.59 Eta Piscium. And there it is there. It's 300 light years away. It's 26 times larger than our sun. There is one Messier object in Pisces. It's a bit over a degree to the east of Eta Piscium, and it is M74, a spiral galaxy. And there it is there, and you can see Eta Piscium on the right hand of the picture. M74 is a large spiral galaxy about 32 million light years away from Earth. It has a magnitude 9.4. However, like everything else in Pisces, this galaxy has a very low surface brightness, and it's very difficult for amateur astronomers to observe. So if you want to see it, it's best viewed under low magnification from a very dark site with excellent sky conditions and preferably no moon. Now, the major feature of Pisces is the end, this circle thing called the circlet, which represents the western fish in the constellation. Again, the stars in the circlet are not very bright. They range in brightness from 3.7 magnitude to 7. And there's 7 stars that define the ring. The circlet does show in my finder scope and would show up in binoculars as well. Telescope has, well, my telescope anyway, has too narrow of a field to see the whole circlet. I can see it in my finder scope, but not in the main scope. So that is Pisces the fish. So we'll go on to space history. Oh. And this is where we look at a past event that not only occurred in this month, but whose anniversary year is divisible by 5. So in 2023, we're looking at events that happen in years ending in a 3 or an 8. Now, last November, this segment was about the final flight of the Soviet Union's N-1 moon rocket and the end of their program to land a man on the moon. And this November, we're going back to the USSR for another flight, another Soviet, what could have been. So this photo was taken 35 years ago this month on November the 15th, 1988, and it appears to be a normal space shuttle landing, but it is not a U.S. flag under the tail, and that runway is not in Florida, it's in Kazakhstan. So this is Buran, the Soviet space shuttle. Buran is Russian for snowstorm. And like their lunar program, the Soviets were late to the shuttle game. After approval in 1972, the United States began construction of their first orbiter in 1974, and it was rolled out in 1976. And in 1981, the space shuttle made its first space flight. Work on the Soviet shuttle didn't begin until 1980, with the first shuttle completed in 1987. And in total, 5 shuttles were planned, but only 1 was ever finished. 2 were nearing completion when the program ended with the collapse of the Soviet Union. Now, at first glance, the Soviet shuttle looks like the American one, and it wouldn't be the first time they've done that. For example, this is an American B-29 bomber. In World War II, a B-29 made an emergency landing in the USSR. The crew was promptly returned because the Soviet Union was allied with us, but they kept the plane. And soon after, the Soviet Tu-4 bomber appeared. And that's it on the right. It looks exactly like a B-29. The Soviets did copy the aerodynamic shape of the U.S. shuttle because that information was freely available, and it did save them a lot of time in the design of their shuttle. But it's not an exact copy. It used similar heat-resistant tiles to survive reentry. It had its own version of the Canadarm, but it was slightly shorter, 36.37 meters versus 37.25 meters for the U.S. shuttle. Had a slightly wider wingspan, 23.92 meters versus 23.8. But it had a slightly larger payload bay and was lower to the ground on its landing gear by a meter. However, it could carry more weight to low Earth orbit than the American shuttle, 30,000 kilograms versus 25,000 for the U.S. shuttle. And that was because it was lighter, but mostly because of how it got into orbit. The American shuttle had three components. You can see the American shuttle on the left. Had a reusable orbiter. It had three powerful engines attached to the orbiter that was used during launch. Two reusable solid rocket motors that fired for 127 seconds into the flight, and a large external tank which fueled the three orbiter engines. And it was also the backbone that held the orbiter and the SRBs all together. The Soviet shuttle was in two parts, the Buran orbiter and the Energia booster. The Energia rose from the ashes of the Soviet N-1 program and used modified versions of the old N-1 engines. It also used the same launch pad that the N-1 was used. Energia had a central core with four single-chambered RD-0120 engines, which burned liquid hydrogen and liquid oxygen. And attached to the core stage were four strap-on liquid-fueled rockets powered by four RD-170 engines burning kerosene and liquid oxygen. At launch, the Energia's core stage and strap-on rockets generated 7.8 million pounds of thrust and was capable of placing 100,000 kilograms into low Earth orbit. The strap-on boosters would burn for 2 minutes and 36 seconds and detach. The core stage would continue to fire up for another 6 minutes, placing Buran into orbit. Energia made its first test flight in 1987, and the booster performed as expected. On November the 15th, 1988, Buran, attached to the Energia booster, lifted off from Baikonur Space Cosmodrome on its maiden flight. And unlike the American shuttle, Buran was unmanned, controlled by onboard computers with some inputs from the ground. Now, because all the engines required to get it into space were on the Energia booster, Buran only had orbital maneuvering system, which it used to change its orbit, attitude, and deorbit. The American shuttle's main engines were 14,000 kilograms of dead weight once it got into space. So without that extra mass of those engines attached to the shuttle, Buran could lift more cargo. It orbited the Earth only twice before firing its engines to deorbit. And there's an artist's impression of Buran in orbit. Buran landed at Baikonur Cosmodrome 3 hours and 25 minutes after it was launched. And despite dealing with a 60-kilometer-an-hour crosswind, Buran systems landed the shuttle only 10 meters from its projected touchdown point. Buran lost 8 tiles during the flight. The flight was hailed as a great success, and more were expected in the future. Let's go let that guy in. In June of 1989, the Soviets took their shuttle to the Paris Air Show, and it was transported atop the Antonov AN-225, the largest and heaviest cargo jet ever built. That plane was purpose-built to carry the Soviet shuttle around on its back. Then it returned to Baikonur. Buran never flew again. The collapse of the USSR starved the space program of funds. Buran, mounted on a completed booster, were mothballed in a hangar at Baikonur. And there you see it there. It was somewhat of a tourist attraction after the collapse of the Soviet Union when they started letting people tour their space facilities, which before were considered top secret. And so people would come and look at this thing. However, on May the 12th, 2002, the roof of the storage hangar collapsed due to lack of maintenance, and Buran and its booster were destroyed. Also, there were a few other shuttle components under construction in that hangar, and they too were destroyed. But you can see a bit of the cockpit there at the bottom of the picture. And there's another picture showing a bit of the orbital maneuvering system at the rear of the shuttle, crushed from the roof coming down. Now, as a postscript, the AN-225, and there was only one of those ever built. They were working on a second one, but they never finished it. It went into commercial service with a Ukrainian company hauling heavy equipment all over the world for many years. It was in Edmonton at least 3 times that I know of, and I've got a video of it taking off. I was impressed by how quiet it was. And the first time it came to Edmonton, it was at the air show at the old Namao Air Base, and I got a chance to walk through it. It is a huge aircraft. But as a sad postscript, the aircraft was destroyed by a Russian airstrike in the opening days of the invasion of Ukraine. And there it is there, completely destroyed. So I put together a little video of some clips I found on YouTube and edited it together of the launch and landing of Buran. And I backed it by a very popular choice of Soviet music from that era, which may be familiar to some of you. Oh, yeah, 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 yeah. And that song is called, and I don't know how it even has a name, it's called I'm Happy to Be Back in Russia, but it doesn't seem to have any words. And if you've ever seen the YouTube video, the guy's mouth hardly moves when he's doing that song. But anyway. So Heavens Above is a great source of all things astronomical. You can print custom maps for any time or place. You can look up if there's comets in the sky, satellite tracking. I'm sure there are Jupiter satellite shadow transit times in there somewhere. It's a great source. Next, What's Up is on Wednesday, November 29th, and that'll be covering the month of December. We have 5 Wednesdays in November, so I'm going to do that on November 29th. And the next RESC regular meeting is on November the 13th at 7:30. Now, normally we do a hybrid meeting. We do it live and we do it on Zoom, but I do not think we're doing it on Zoom because we're going to be doing it in the IMAX theater, not the Ziegler theater. And we're going to be showing an IMAX movie, and there's copyright stuff. So it's not going to be on Zoom. And there'll be other stuff going on too, our regular features like Astro Imaging Corner and that. But if you want to see the meeting, you got to come to the TELUS World of Science, and it'll be in the IMAX theater.
With actually, the first half, Jeff, will be on Zoom.
It will be now.
The first half, which will be the Astro Imaging Corner and a presentation about BNLO.
Oh, okay.
And but after the break, then that'll end the Zoom session, and the IMAX movie will be in person only.
Ah, okay, all right. Well, things have changed since the council meeting.
Yeah.
Okay, all right. Well, I stand corrected. Okay. And that's it with, I see another chat here. What does that say? Oh, okay. Somebody was laughing. All right, well, that's it. Are there any questions, comments, anything? No.
Sorry. Yeah. The whole Russian space shuttle thing is actually new to me. I'm not as big a space enthusiast as you are, so I learn a lot watching these. So thank you.
Oh, yeah.
I do remember reading something about the payload, which is you had mentioned about how their payload was bigger than the space shuttles, and I do remember comments about which is better, the U.S. program, the Soviet program, and somebody just it was sort of the U.S. has all these wonderful high tech space infrastructure stuff, and somebody else sort of slyly pointed out that the Soviets have more low Earth orbit stuff than the U.S. does because it's got what did they call it, the big dumb booster approach.
Yeah, they do have, like, the Energia was had more combined thrust at liftoff than the Saturn V did.
Wow.
And but they only flew it twice, and there aren't any more. What impressed me, because it was such a huge rocket, and the way they got it to the launch pad. Well, here, this one book. I don't know if it'll show, but no, it's not going to show. Anyway, they transported it horizontally, and then they stood it up at the launch pad, where, of course, the shuttle they put together and transported it vertically out of the vehicle assembly building. I just wonder, geez, how did they stand that thing up?
A little bit farther. No.
Yeah. Oh, no, not too far. Whoa. Yeah. But it was quite impressive that, they flew this thing unmanned. They say the American shuttle could fly unmanned too, but a lot of it was flown by computer. The final stage of landing was always the pilot's control, because no pilot worth his salt is going to let a computer land his plane. It's like, the modern Airbus is, passenger planes. Pilot's always flying. You're not going to let some computer take his job. Although maybe this show I watch, maybe I'm a bit of a masochist. The show Mayday, which is about plane disasters. There was one episode when they were talking about computer systems in the plane, and they were talking about in the future they're going to have a pilot and a dog in the cockpit, and the pilot's just
that
there.
Cartoon. Oops, sorry. Go ahead.
Yeah. Anyway, the pilot's there just because you need a pilot, and the dog's there to bite the pilot if he ever tries to fly the plane. So,
well, with the move to driverless cars, and knowing how good the computer plane landings have been, one of the things that I proposed was it won't be long before you see the pilots, all of them sitting in some central facility in Utah, remote piloting all the planes that are up there.
yeah.
And I think it's one of those things where we can do that, but probably somebody would be sued their pants off if they actually tried it.
Oh, yeah. I
Well, the
mean,
military does it with drones.
Yeah.
that's true. Yeah.
They're flown from an office in Nevada.
Yeah. Yeah, I know. It's, like the first time I went on the SkyTrain, that was back in '86 when I went to Expo, and they said, there's nobody driving this thing. I was a little worried. I always feel better if there's somebody at the front that's, driving the ship,
I just picked up a new book a few days ago.
Yeah.
Oh, yeah, the collision of the two 747s.
Would not have happened if computers were flying that.
Yeah.
Well, wouldn't have happened if it wasn't foggy.
Yeah. And the KLM guy was a little too anxious to get off the ground.
Yeah, that was, and the funny thing was he was chief of the pilot safety program.
Yeah.
Was it? I haven't read it yet. Like, I knew about it, but
Yeah, it showed up as a case study in another book to the title of something like Why Smart People Do Dumb Things. Yeah.
Okay.
But yeah, that's what Elon Musk said about the advancing of all the space exploration and colonization that we're doing is, all of the gas station attendants. That's all going to be computers. You aren't going to have human gas station attendants in low Earth orbit, coupling pipes together to gas up the various rockets. It's all going to be automated.
Yeah, I could see that. Yeah. I could see that. Yeah. A different world, that's for sure.
Yeah.
Yeah. Anyway, okay. Well, if there's nothing else, I will say thank you very much for
And
taking a few minutes to join us tonight. This has been recorded. I will edit it and put it on YouTube in a day or so, if you want to watch it again or tell your friends. And yeah, you had something to say, Alistair?
I was about to say, make November go away.
Oh, yeah. Yeah. Hopefully we'll have some clear nights. It was when I came downstairs to do this, it looked kind of clear. I don't know what it's like right now, but
I have a school presentation tomorrow morning for Venus and the Moon, and maybe
Maybe. Okay. All right. Okay. All right. Well, thanks
Good night,
again.
all.
And hopefully we'll see you next on the 29th. So have a good November.
Night.
Thanks, Jeff.
Yep.
Thanks,
Good night.
Jeff.
Thank you.